This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations.
Calm down, I'm moving too fast.
This Master Brewers podcast is proudly sponsored by Hopsteiner, a global leader in the hop industry focused on quality, sustainability, and innovation in new hop varieties and hop products. Contact our brewery sales team to provide you with the hop-related tools you need to craft your next great beer. For more information, visit hopsteiner.com.
Additional support provided by
Draft Lab knows that quality and consistency are your brewery's top priorities. Draft Lab provides easy-to-use sensory analysis tools designed to bring your tasting data into action. To start your free 2-week trial today, visit draftlab.com. That's DRAUGHT lab.com.
Part of the inspiration for getting these numbers was to try and know what we're getting so that we can attempt to achieve some sort of brand consistency amongst our different brew houses. And after kind of crunching the numbers and realizing that we may actually be aerating a lot more than I think we are.
This week on the show, how much dissolved oxygen is in your wort? Today's guest set out to answer that question without breaking the bank.
My name is Derek Dawson. I work at Modern Times Beer here in San Diego, California.
Tell us how you aerated wort at Modern Times prior to this project.
Yeah, so prior to this project, I don't want to say it was kind of a guessing game, but we had our oxygen flow meter set up there. It was kind of a large scale one. I think it went from 0 to 15 liters per minute, 0 to 20, something in that range. And it was set up not arbitrarily. It worked for us, but there was not necessarily any data that went with it, or we didn't necessarily know exactly what numbers we were hitting. We could guess at that to try and see what was going on. But physically, it was the same setup as we had now. We've made some tweaks and adjustments based on data that we've collected since then. But prior to doing any of this work, it was simply coming out of the heat exchanger, going through a 4-inch sintered stone that was hooked up to our oxygen tank through about 80 feet of soft 1.5-inch line into the bottom of the fermenter. So physically the same as now. But it was using a different flow meter on the oxygen side than what we've implemented since then. Did you have a sense of whether you were under or overdoing it with that method? I kind of was leaning towards it. We had been coming across a little bit of some flavor stability issues with some of our beers. And after kind of knocking our heads against the wall and trying some different things, we thought it might be an over aeration thing going on. Which is what kind of led to me looking into this and obtaining a parts per million DO meter that we could use to kind of track this data and get that info. So, yeah, it was some curiosity. I think we were always curious exactly what was happening since we were kind of just guessing at it. But at the same time, I think the kind of wonky flavor stability was what kind of drove us to actually start tracking some numbers on this.
Had you been tracking peak cell counts or fermentation times or any other metrics that sort of supported that inclination?
Yeah, we've been, viability of every tank in the cone afterwards as we're cropping, apparent degree of fermentation, force fermentations we're doing on every tank as we go. So these were some of the data points that we were getting, along with sensory evaluations along the way. Obviously we're tasting every tank throughout the process, mid-firm, post-firm, pre-dry hop, post-dry hop, all those kinds of things. So kind of lining those up with our other numbers were the main tests that we were running there.
Okay, so you wanted to get to the bottom of this and get some real data. Talk about your setup for this project. Where and how did you measure wort DO?
Sure. So that setup that I kind of described earlier, for what the knockout line looked like coming out of the heat exchanger, that essentially, the first time around I tried this, I should mention, initially I thought the DO meter was broken when we got it. I set it up at the bottom of the fermenter, put a T on there, put a Zwickel on there. And that was kind of my sample station where I would be taking readings. And initially, with that old oxygen flow meter that went up to 1520 liters per minute, it had not a great resolution on it, right? As soon as I could get that little ball to move and see the flow actually kind of get going through that, we were maybe up in the a couple liters per minute just because the resolution wasn't that great. And my oxygen, dissolved oxygen meter actually maxes out at 20 ppm. So 20 milligrams per liter. If anything above that, it's not going to read. And when I had initially set this up the first time around, I was not able to actually even get any readings below that were able to register on the HANA meter. So I was like, what's going on here? Is this thing busted? And after kind of crunching the numbers and realizing that we may actually be aerating a lot more than I think we are, I got a hold of one that went from about 0 to 3 liters per minute. So that allowed me to adjust the resolution down into about an eighth of a liter per minute, a quarter of a liter per minute, a half of a liter per minute.
Yeah, I've seen some. There's some interesting. You can get some pediatric oxygen meters, for the medical industry that give you sort of more precise control at those low flow rates.
Mm-hmm. Yeah, and that was necessary for us to kind of look into that and read that. And I've actually since had a couple of people come up to me and tell me they've experienced the same thing where they thought they were, getting a certain amount in there, and they actually had to go significantly lower than what they thought in order to read that. So that was finally allowed me to, dial in. The actual process for this would be setting the flow rate on our oxygen flow meter to say an eighth of a liter per minute, and then I would, wait to make sure that that wort had time to hit the bottom of the fermenter. I would then take a reading, wait for my reading to stabilize down there with my dissolved oxygen meter, go adjust go back, record my reading, go back, adjust my oxygen flow meter to a quarter, a half, kind of keep going up from there and continue to take readings at the tank bottom until I had enough data. And eventually it would get off the chart and beyond what my meter could read. But it allowed me to kind of correlate those dissolved oxygen numbers at the bottom of the tank with actual flow rates so that I could kind of line that up with, the knockout rate of the rate of the flow of the wort as it left the brew house as well.
I assume you didn't already, I think you said earlier that you didn't already have instrumentation capable of measuring dissolved oxygen in the target range. How did you decide which meter to get?
That was not a ton of thought went into that other than something that we could afford at the time. So this one I think was, a few $100, maybe $400 or $500, something like that. And I think, we were under the assumption literature kind of talks about 8 to 10 ppm in a tank, maybe for loggers, or sometimes you see a little higher than that. Sometimes you see 14, 16 ppm for kind of target ranges. So I think because everything had been working out for us up until this point, we thought we were within that range. And so we purchased a meter that fell within that range to let us know that we were in fact hitting that or maybe going under, but didn't really have any idea that it was going to exceed that or kind of be a lot bigger than that. So if I were to do this over, I would probably grab a meter that can read obviously higher than that, and I have to look into what models do that. But I think that would be beneficial if I were to kind of start over.
Very good. So do you have any tips for getting accurate measurements with that setup you described? For example, I know I did this something very similar to this years ago, and I believe we had just the Zwickel at the T at the tank at the bottom. We had that just kind of constantly flowing very slowly into a beaker, and then the probe or the meter was submerged into there. We ended up putting like a set of pigtails on this wickle to kind of calm the flow down as it was coming out of there. Do you have any other tips like that for really getting a good reading with that process?
What you just described is kind of precisely what I did as well. So that having that Zwickle on the end, flowing into a beaker, and with these types of probes, they require a constant stream, as you know, of wort to be flowing over them in order to properly read. So having just the Zwickle constantly open, not blasting it out or anything, but also not dripping out, getting a nice steady flow. And then in the same fashion of you using that pigtail to make sure there's no agitation from the atmosphere. I'm having the beaker, the tip of the Zwickle be under the level of the surface of the liquid of the wort as it's overflowing out of the beaker, so that it's not necessarily introducing any environmental oxygen into the picture and kind of pulling it in there. But exactly kind of what you just described is how I was running it.
Coming up,
we were kind of treating all of our yeast strains equally in terms of how they uptake oxygen and what their preference is. And this allowed us to kind of split that out and better understand how each of those utilize oxygen and what that looks like.
I'm John Bryce, and you're listening to the Master Brewers Podcast from the Master Brewers Association of the Americas.
This Master Brewers Podcast is proudly sponsored by Barna Mechanical, a full-service design build firm specializing in turnkey process and utility systems for the brewing industry. We partner with some of the best craft brewers in the U.S. to ensure the great beer they brew is what their customers get in every glass, bottle, can, or keg. You know beer. We know breweries.
Additional support provided by
ABS Commercial is a full-service brewery and parts outfitter. From our Raleigh headquarters to our Denver office, we proudly offer brew houses and fermenters from 3 barrels and up, yeast brinks, boilers, kegs, chillers, tri-clamp, and other stainless parts, all with the quickest delivery and lead times in the industry. Learn more at abs-commercial.com or call 877-BREW-ABS. ABS Commercial. We are brewers.
Here's what's coming up on the Master Brewers calendar. District Pittsburgh has their fall meeting at Mindful Brewing September 24th. The 2018 District Ontario Iron Brewer September 28th. District Southern California meets in San Diego September 29th. Founders Brewing is hosting the Master Brewers HACCP course in Grand Rapids October 1st and 2nd. The District Northwest fall meeting is in Yakima October 12th and 13th. Don't miss the Can Seaming webinar October 19th. District Philly meets October 19th and 20th. And the Master Brewers 2-week Brewing and Malting Science course begins in Madison October 21st. View the full calendar of events at mbaa.com for more details or to find a district meeting near you. Now back to the show. Walk us through some theoretical numbers before we talk about what you actually observed.
Sure. I had always been curious, even kind of before running this experiment, what the solubility of oxygen is at this point in this gas-deprived wort as it's leaving the heat exchanger. We know, you can crunch the numbers and figure out that in 1 liter of oxygen, 1 liter of O2, there's a little more than 1.4 grams of oxygen present in that volume. So if you injected a certain amount of liters of oxygen through your knockout, then you know exactly how much O2 kind of went in there. And I've always been curious, if we can put a number behind the solubility there, it would make it pretty easy to then go through and say, whether that's 80%, 100%, if it's linear, even if it's not, you could write up an equation that would allow you to take the, rate of flow of wort as it leaves your brew house alongside the rate of flow of oxygen and kind of just say, all right, this much of it is dissolved in there. And allow some brewers that don't have this kind of instrumentation to have a much better estimation of what their DO levels are in the tank. So the theoretical numbers would be, for our brew house, we knock out at around 19.5 gallons per minute. That's just the average kind of knockout rate with our system. I kind of, made a chart of this is what I would expect to see at 100% solubility. If 100% of our oxygen was dissolved into solution at 1 liter per minute on our brew house at that knockout rate, we should see about 18 to 20 ppm.
That's interesting. So what'd you actually get, and was it a surprise to you?
It was actually pretty surprising. I was not expecting to see numbers that correlated so closely and so linearly, let alone it being right up there near 100% solubility in the wort. It actually tracked extremely closely. That number that I just mentioned for 1 liter per minute, what we actually read, what I had at the tank bottom was 18.1 ppm when I would have expected about 19 ppm at 100% solubility. So those numbers tracked in a very linear fashion. And I kind of charted it out to see, this is what we expect to see. This is what actually came through. But I, for all intents and purposes of, having brewers estimate this, recommend 100% solubility and not even adding a cofactor in for anything less than that. We saw plus or minus around 10% tracking with the numbers that I would have expected to see if 100% of it went into solution. Sampling error, I'm sure, those numbers on the meters are kind of moving a little bit, going up and down as you're taking the sample. So it was all well within the range of kind of me being okay, at least on our production operation, saying, yeah, let's go ahead and account for 100% of it being dissolved in, and then let's go ahead and adjust that based on our flow rate of our knockout and say good to go with it.
What flow rates did you start off at before this project? Like, how much did you come down?
In terms of what we did for our production beers before versus after?
Right.
Before, it's interesting. So I mentioned those kind of flavor stability issues that we were playing with. We initially backed off significantly I want to say we were up on our brew house around 4 liters per minute, 4 liters per minute. And we actually backed it down to around 1, maybe in between 1 to 2 for higher gravity stuff. And that initially helped our off flavor that we were getting. And so we thought, okay, great, this is fantastic. Over aeration seemed to be the issue, but we kind of ran into the problem there of not fully attenuating on one of our specific yeast strains. I didn't realize how strain specific this aeration really was in terms of fermentation. But our Chico, our Saison, and our Augustiner, they reacted fine. They were okay with it, with the lower oxygen levels, both in terms of flavor and attenuation. But our London 3 strain that we used just did not want to finish. We saw, about a 10% drop in apparent degree of fermentation on there. And so we actually ended up bumping that back up. But instead of bumping it up and having it kind of continue through all the knockouts like we usually do, we stopped aerating sooner. It takes us about 6 to 8 turns to fill our tanks, 6 to 8 turns to the brew house. And we were aerating maybe half of those turns, depending on how the split lined up. So we kind of came to a compromise where we're still right now currently aerating about 2 to 3 liters per minute. So a little bit less than we were before, higher than we were when we made that adjustment. But in order, we've kind of learned that we're able to eliminate that kind of flavor issue by just aerating not into those later turns as late as we were.
Very good. Did you observe any other benefits of sort of, decreasing the overall flow rate and amount of oxygen getting pumped in? For example, I'm wondering if you noticed perhaps better beer foam stability at the lower flow rates with, not using up as many foam positive proteins, that sort of thing.
That would be a great test to run. I did not necessarily take a good look at that to be able to give you some evidence that that was the case either way. We didn't have any necessarily difference in foam. We do track as best we can every finished beer in terms of appearance as well. So lacing, foam, quantity, quality, that kind of thing on our finished beers. But there's nothing that we did kind of scientifically to look at those particular batches before versus after. But we taste all our beers, and none of us have really here at the brewery noticed anything that has improved that, so to speak, I should say.
Let's talk about some of the variables that are going to have an impact on this process. How about the length of your hose between your heat exchanger and your fermenter? Is that always the same? And if not, have you observed different results at various hose lengths?
Sure. That's a great question. That is always the same for us. We kind of just drag around the same, measure out a knockout line that's long enough for our farthest away fermenter, and then just drag that closer for the fermenters that are closer to our brew house. So that doesn't change. That variable doesn't change. But that's always been a curiosity to me. And what I'd like to do is kind of take these numbers and validate it against our Portland brew house and maybe our Los Angeles brew house. That was kind of part of the inspiration for getting these numbers, was to try and know what we're getting so that we can attempt to achieve some sort of brand consistency amongst our different brew houses. So having the numbers from our main production facility down here in San Diego, I'd like to take that up there using obviously different setup, different knockout line length, and see if those numbers correlate or not. I've heard kind of estimates on both sides. I've heard people say, the longer the line, the more time the O2 has to tumble around in there and dissolve in a solution. And I've heard kind of the opposite, like the shorter the line, the quicker it's just able to, or I guess the less time it has to break out a solution, sort of thing. So I don't have a definitive answer on that, but I would definitely like to try it with different line lengths.
Yeah, I can't remember if it's more or less, but I can tell you it's definitely different. And so I think what you're doing is the best practice to make sure that you are always using sort of the longest line, even if you're going a short distance. I think that's going to give you a much more consistent result. How about back pressure? Do you ever have back pressure on your fermenters during filling, or are these all, blowing off as they're going?
They're all blowing off. Yeah, they're all blowing off as they're going. And obviously the only addition of back pressure is going to be that hydrostatic pressure as the tanks get fuller and fuller. But our knockout rate of our wort, we're boosting our pump speed on the brew house to make up for that, so that we're always knocking out around the same speed.
Any variation in temperature is going to have an effect. What did you observe there as you were doing your trials? Did you have much fluctuation in the wort temperature? Were you able to see that make a big difference?
That is another, that along with wort gravity are the two that I would like to run some more numbers on to get. This one was knocked out at 66 Fahrenheit, the kind of one that I ran this big trial on, and to gather all these numbers. And that most 95% of our beers are all knocked out 66, 68 Fahrenheit. We do a lager that we knock out colder, and we used to do a saison that we knocked out warmer, but we don't anymore. So it's just that one lager that gets knocked out cooler. But for us, it's going to pretty much always be in that 66 to 68 range. But I think that would be, clearly that's got to have a difference, right? That has to make a difference on what we see in terms of solubility. And I would have to think that wort gravity as well. This trial that I ran was 19 Plato wort, so fairly high, which is another reason that I was kind of surprised that much stayed in solution. I don't know why, but my hypothesis would have been that the higher gravities would have been tougher to dissolve as easily, that much oxygen into it. And maybe that is the case, and I just need to run more trials to see. But it would be nice to do it on maybe an 11, 12 Plato wort, and then maybe again on a super, super high, like a 28 Plato wort, and kind of see how that falls on both sides of it.
Yeah, definitely. Another thing to think about too is just the stone itself. It's possible that sometimes you can get fouling on the stone. If there's several brews have gone in before it's been cleaned, and sometimes you can get different results with the same settings there. So that's definitely something to keep an eye on. And then also, as you experienced, I think just having the right equipment. So like you said, if your meter doesn't really give you the ability to really dial it in, you can see some pretty massive variability. So I think that it's worth the investment. You can get these. There's different types of flow meters, like the one you described with the ball that floats. I've seen a lot of those. Those used to be sort of ubiquitous within the industry, and those are really hard to dial in. Whereas the one you have now, is that more of like where the wheel just kind of clicks and it locks on the setting, or how does that work?
No, it's actually still the same style. It's a different manufacturer, but it's just a lower resolution, but it is still the same floating ball style.
Yeah. So, that's another thing to think about too, is just getting the meters that can kind of dial it in more precisely. So great. Any other process changes that were a result from this work?
I think it was a really good learning experience for us at the brewery to kind of, we were just throwing darts at a kind of big target, and this helped us kind of narrow that target down to what we think we're aiming for, what we're actually aiming for, what our various strains like. We were kind of treating all of our yeast strains equally in terms of how they uptake oxygen and what their preference is. And this allowed us to kind of split that out and better understand how each of those utilize oxygen and what that looks like. The only other really big process change would have been how late we're aerating. We found we had to kind of keep that higher rate for our London strain, that higher oxygenation rate for our London strain to remain happy. But in order to kind of account for flavor issues, it was just making sure that it's just the first couple turns, and our splits can be kind of wonky here depending on the timing of a production facility. And oftentimes we're moving from one tank 3 turns, moving to another tank for a couple turns, going back to that tank and letting the yeast kind of replicate in there before we finish knocking out. So kind of timing those splits better is something that came out of this experiment as well, and making sure that we're not leaving too much time, and that we're not aerating those later turns, because that kind of led to these kind of wonky off flavors that we weren't really happy with. So the timing of the oxygen, the timing of the splits, I think is just as crucial as the amount that you're pumping in there.
That was Derek Dawson here on the Master Brewers Podcast. If you'd like to see the data and calculations from the Wort Aeration trials Derek did at Modern Times, look out for the 2018 Brewing Summit proceedings, which go on sale soon at mbaa.com/store. 130 years ago, Master Brewers was built on the concept of brewers helping each other out so we could all make the best possible beer. That's still true to this day, and it's where a lot of the camaraderie in this industry originated. Master Brewers' award-winning Ask the Brewmasters is the best place to go for troubleshooting, where you'll find the industry's only discussion forum that's moderated for technical accuracy by a team of experts. See what everyone else is talking about at community.mbaa.com. Did you enjoy today's episode? Would you like us to keep making more? If so, there's a really simple way you can let us know. Subscribe, rate, and review the Master Brewers Podcast on iTunes, Stitcher, or wherever you get your podcasts.
My fist full of courage, my heart full of rage. Well, I can't get stuck, I can't be losing too much.